Welcome to another session in Engineering Data Analysis. This is still your Professor Nadine Alex Bravo. This is a continuation of our third module, Discrete Random Variables and Probability Distributions. And for this topic, or for this session, we are going to discuss binomial distribution. So everything we're going to discuss from the second session until the sixth session are just brief introductions of these respective topics. Okay, for the completion of knowledge of everyone. Okay, so mapapansin natin that from understanding what discrete probability distributions are, we probably have noticed based on the some problems na na-solve nyo na in the previous chapter, kagaya ng sinabi nyo before, may mga problems naman na nauulit-ulit lang, nag-iiba-iba lang ng way kung paano siya isa-solve. So, ganun nga, may mga experiments wherein the outcomes, kahit magkakaiba yung experiments natin, pero yung behavior ng outcomes natin, pare-parehas lang. And because of these similarities, we were able to group them or categorize them into special discrete probability distributions. Yun nga is after knowing that several experiments behave in the same manner. Okay, so one of the special discrete probability distribution is binomial distribution, and this happens because may mga experiment tayo na kung saan nagko-consist siya of repeated trials or ginagawa natin ng paulit-ulit yung experiment natin. Like for example, yung ating toss coin, di ba? Pwede mong paulit-ulitin yung number of times that you toss the coin, but it doesn't change the outcomes in every toss of the coin. Okay? Nagkakaroon lang ng additional numbers in the possible outcomes if we are considering the number of tosses we are doing. Ganon din yung mga what's that? Picking out components from an assembly line, 'di ba? And then identifying them whether they are defective or non-defective. Kahit ilang beses ka mag-pick out doon, the component will fall into one of the two characteristics, whether they are defective or non-defective. And it doesn't change. It doesn't change how equally likely for a certain product or component to be part of one of the two descriptions. So, masasabi natin na Bernoulli ang isang process, or that it will be considered a Bernoulli trial and produce a binomial distribution if it is able to possess the following properties. So number 1, the experiment consists of repeated trials. So ilang beses natin ginagawa yung experiment, kagaya nga ng sinabi ko sa inyo, pagkuha ng gamit from the assembly line or pagtetest or pag-observe ng product, whether they are defective and non-defective. Diba ilang products yung tinetest natin from a certain sample? So that is considered a repeated trial. Each trial results in an outcome that may be classified as success or a failure. So, yung bawat trial daw natin, yung outcome na yon can fall into either it is a success or a failure depending on the objective of the researcher in the experiment. So, halimbawa, ang iyong objective sa pag-pick out ng components in the assembly line is to determine whether a component is defective. That will be our success. Ibig sabihin, success not in the sense of a business matter, okay? Success in the sense that you are able to obtain your goal, and that goal is to find a defective component. So, if your success is obtaining a defective component, then your failure in terms of your goal is having the component non-defective, or it could be kabaliktaran, 'di ba? Your success could be getting a non-defective, and then your failure could be getting a defective. So, it depends upon your goal in your experiment. The probability of success, so ito yung denoted by P. Ibig sabihin, ito yung classification which you consider as your goal or your focus in the study. Okay? So, yung probability ng success natin will be denoted by small letter P, and this remains constant from trial to trial. Okay? Ibig sabihin, in short, every experiment or every trial is considered to be independent from each other. In short, one trial does not affect the result of the other trial, and no trial is dependent to another trial. So in short, independent trials po ito. Hindi naaapektuhan ang probability ng success natin in every trial. Okay? Next is, the repeated trials are independent. Yan na nga po yun. So, this is related to this one. Okay? So, if these four properties are met by your experiment, then it's considered a Bernoulli process. So, consider the set of Bernoulli trials where 3 items are selected at random from the manufacturing process. Yung selection of 3 items tells us about the number of trials we're doing the experiment. Ito yung repeated trials natin. So, 3 beses tayong magta-try kumuha ng item from the manufacturing process. This is inspected and classified as defective or non-defective. So, a defective item is designated a success. Ibig sabihin, pag nakakuha tayo ng defective, yun yung probability P natin from the previous slide. The number of successes is a random variable X. So, ang focus natin ngayon dito is yung bilang ng success na makukuha natin. Or in short, yung bilang ng, ano ba yung success natin? Getting a defective. Diba? So, yung bilang ng defective item na makukuha natin, assuming integral values from 0 to 3. Bakit 0 to 3? Because you have 3 trials, 'di ba? You have 3 trials. So, pwedeng in those 3 trials, 0 success tayo. Ibig sabihin wala tayong nakukuha na defective. Pwedeng 1 lang yung success natin. 2 or 3. Ibig sabihin lahat ng 3 items na kinuha natin are all successful, meaning they are all defective. So, we will have 8 possible outcomes. And the corresponding values of X are the following. Okay? So, I'm sure you understand why there are 8 possible outcomes. Diba? Yun yung 2 by 2 by 2 natin. 3 trials to. So, that would be, your total number of items would be 2 times 2 times 2, which is 8. Dahil you have 2 possible outcomes for the first item you'll get in the process. 2 again for the next, and 2 again for the third. So, you have 8 possible outcomes. Those 8 possible outcomes ay ito. You have NNN, NDN, NND, etc. And the random values of these outcomes are written below them. So here you get 0 because you do not have a success. You do not have a defective item. So you get here 1, 1, 1 because each of these get 1 item defective. And then here you get 2 because in each of these outcomes you have 2 defectives, right? And then the last outcome is gets a random value of 3 because all 3 outcomes are defective. Now, so since the items are selected independently and we assume that the process produces 25% defectives, ibig sabihin lahat daw ng dumadaan dun sa manufacturing process, the probability daw of getting a defective is simply 0.25. And that gives you your P, diba? That gives you your P. Or, if you will be solving for the probability of one of this, let's take for example, we're solving for the probability of NDN, getting an NDN outcome. Since ito ay independent, we simply multiply the probability of each trial. So, you have there the probability of non-defective, probability of defective times probability of none. So, ang probability ng defective natin is 0.25 as mentioned here because the process creates 25% defective. So, by complementary event, ibig sabihin ng probability ng non-defective natin would be 0.75. And there goes, and in this solution, it shows us that 0.75 is 3/4. That's for P, probability of N. And then you get 0.25 or 1/4 for probability of defective. And then another 3/4 for probability of non-defective. Multiplying all these 3, you get an answer which is 9/64. And if you're going to do this, to create a probability distribution, you will obtain this table. Okay, so if you have 0, ibig sabihin, wala kang defective item na nakuha, then you'll get 3/4 cube, diba? 3/4 cube. If you have 1 defective, then you'll have, if you have 1 defective, the probability of the random variable being equal to 1, ibig sabihin, you will have here, isa lang yung defective natin. So, you get 1.25, and then, since 3 trials to, you'll get 0.75 squared. Okay? But ang question here is, how many arrangements do we have wherein you have 1 one defective item. So automatic that's 3, diba? If you'll go back to this list, you have this 1, 2, 3. You have 3 answers or 3 outcomes with just one success or one successful outcome. So we are going to multiply this by 3 to get the total probability of all items with one defective item or one defective lot. We can test that through our calculator. So you can see that gives us 0.25 times 0.75 squared times 3. You get an answer which is 0.421875, and that is 27 over 64. So you're going to do the same thing on the remaining ones to create this probability distribution, this discrete probability distribution. And this probability distribution is what you call your binomial distribution. So the number x of successes in n Bernoulli trials, okay, ibig sabihin yun yung repeated trial natin, is called your binomial random variable. So your binomial random variable is the variable x, which represents the success in your n Bernoulli trials. So the probability distribution of this discrete random variable is called the binomial distribution, and the binomial distribution will follow your binomial experiment. Ibig sabihin, we are executing Bernoulli process or Bernoulli trials. Okay? Thus, the probability mass function of your binomial random variable, which represents the number of successes in n Bernoulli trials, is simply n of x or n combination x, probability of success raised to x multiplied by 1 minus probability of success raised to n minus x. So, ang mapapansin nyo dito, we can write this in a different manner. Kasi baka malito kayo dun sa symbol na ginagamit, Pero ganyan talaga sa ibang reference book. So, this one will represent the probability mass function of your binomial distribution. So, ito yon. And your n combination x may be written as ncx. And then this is your probability of success raised to x, your number of successes. Okay? Multiplied by 1 minus p. This is the complement of success, which means this is failure. Diba? This one is success. And if you're going to notice, the exponent of failure is n minus x, which means if x is the number of success, diba? X is the number of successes. If you get the difference between the number of trials minus your successes, it gives you the number of failures. So, parang anong nangyari dito? Probability of success raised to number of successes, probability of failure raised to number of failures. And that gives you the formula we're going to use for binomial distribution. It's important here that you understand na yung experiment pala na ginagawa mo or the experiment you're solving is a binomial distribution na for you to be able to use the formula. Okay? So, the probability P or the probability of success in a single trial must be less than 1 or greater than 0. So, it should be in between 0 and 1. Okay? So, to illustrate this, each sample of water has a 10% chance of containing a particular organic pollutant. Assume that the samples are independent with regard to the presence of the pollutant. Question, find the probability that in the next 18 samples exactly 2 contain the pollutant. Determine the probability that at least 4 samples contain the pollutant. Okay, so solving for this, let's get our notes to show you how we are going to solve this. This particular experiment is considered binomial because it already mentioned that we are going to, the samples, picking out a sample or taking a sample of water are independent with regards to the presence of the pollutant. Also, you have letter A question which supports that you will be testing several items. And there are 18 samples. So, yung 18 times nakukuha tayo ng sample of water to test for the pollutant. Let me write here binomial first. Okay. So, the mere fact that you are solving for 18 samples, you're going to test the content of the water in 18 samples, that already signifies that you have several trials to do. And that represents your N. In question letter A, okay, so we also have here P. Yung probability natin dito of success is 0.10. That's the probability of, kasi yun yung yun yung focus natin dito. In letter A, you are being asked to know the probability of getting a sample that contains a pollutant. So, ibig sabihin, that is your success. Ito yung definition mo ng success, getting a pollutant. And the probability to have a pollutant in the water is 10%. So, that will represent your P. That's 0.10. Okay, so ang first question is, what is the probability that you get exactly 2 out of the 18 samples? Which means, yun yung magre-represent ng X mo sa solution natin. So, if I'm solving for f of 2, that would be NCX, di ba? That would be NCX, let me write down the formula. NCX, P raised to X, 1 minus P raised to N minus X. So, if I'm solving for f of 2, that would be an N of 18, combination 2. Okay, the probability is 0.10 raised to 2 multiplied by 0.9 or 0.90 raised to 16. That's 18 minus 2. So, dito mo lang yung kukunin. Difference itong dalawa. And getting again our calculator to show you the answer. That's 18 combination 2 times 0.10 squared times 0.9 raised to 16. Okay? And that gives us, wow, yan, that gives us a probability equivalent to 0.2835. So, you get 28.35% chance that in 18 samples, you have 2 of them containing the pollutant. Okay, let's proceed to letter B question. So, question letter B asks us to determine the probability that at least 4 samples contain the pollutant. So, alam na natin to. When we say at least, ibig sabihin, magsisimula tayo dito because minimum of 4. So, ang maximum mo hanggang 18, which means, di ba ang tinatanong sa atin is probability that at least 4 samples contain the pollutant, di ba? Okay. Pag sinabi mong probability of at least 4, ibig sabihin, let's say probability of X is greater than or equal to 4, di ba? It could be equal to 4, it could be greater than 4 because at least yon minimum number. So, ang mangyayari ngayon dito, until we exhaust all the samples, kukuhanin mo yung sum ng probability from 4 hanggang 18. Probability of X equal to 5 plus ... until you get the probability until X is equivalent to 18. Ganun kadami yung kukunin natin. So, instead of doing this ng mano-mano, pwede natin tong gawin using summation notation, di ba? If you understand how to use your summation solution, the probability of getting X greater than or equal to 4 is simply equivalent to the summation of. Okay. To the summation of, ano bang magbabago? Ang magbabago ay, ito, di ba? The number of trials doesn't change. It's still 18. Combination. So, this particular variable changes. So, we're going to write here X. Okay. X is equivalent to 4. Doon tayo magsisimula. And it will end until 18. Okay, so, we're going to take the sum with X from X equal to 4 until X equal to 18. Multiply that by the probability doesn't change. That's 0.10. But the exponent changes. That's your X. Multiplied by 0.9. Okay, 0.9 raised to N minus X. Your number of trials doesn't change, so that's 18 minus X. If you're going to write that or type that in your calculator, you have to take your summation. Okay, so shift, summation. You have there 18 combination alpha X for that variable X. And then you're going to multiply that with 0.10 raised to X raised to alpha X. And then, we're going to multiply this by 0.9 raised to, that's 18 minus alpha X. Okay? And then, you will be solving this from an initial value of 4 until you get the sum to 18 samples. Okay. So, that gives us a probability equivalent to 0.0982 or 9.82%. Or, alternatively, pwede natin gawin dito is, for the probability of x greater than or equal to 4, pwede tayong mag-complementary events dito, di ba? Pwedeng 1 minus, tanggalin mo yung hindi 4 pataas. Ibig sabihin that would be 3 pababa. Which means you're going to subtract all probabilities where x is less than or equal to 3. Okay, so ang mangyayari ngayon dito, this will be 1 minus the summation, mag-summation na lang tayo ulit. The summation of n combination x. So, yung n natin is 18. Combination x, the probability of success is 0.10 pa din, raised to x. And failure is 0.9 raised to 18 minus x. And we're going to get this answer with x equal to 0 until 3. Okay, so typing that in our calculator, we have 1. Okay, so we have 1 minus the summation of, you have 18 combination, 18 combination alpha x multiplied by 0.10 raised to alpha x multiplied by 0.9 raised to 18 minus alpha x. 18 minus alpha x, and we're going to take the sum from 0 to 3. Okay, and that gives us the same answer. So you have here the probability of x greater than or equal to 4 equal to 0.0982. Okay, that will make it easier for us to solve questions like this. Okay, next. So a dog manufacturer is promoting a new brand with a rebate offer on its 25-pound bag. Each package is supposed to contain a mail-in coupon for 4 pesos. So, bawat 25-pound bag daw, dapat meron siyang laman na 4 peso discount. Okay? However, the company has found that the machine dispensing this fails to place a coupon in 10% of the bag. So, ibig sabihin, a probability of 10% means there will be no coupon in that particular 25-pound bag. Enticed by the large rebate offer, an owner of 2 Airedales purchases 5 bags. So, find the probability that one of the bags will not contain a coupon. Ibig sabihin, itong purchase niya na 5 bags, yun yung magre-represent ng number of trials natin. And we are interested to take the probability that it will not contain a coupon. So, not having a coupon in the bag gives you your success equivalent to 0.10 ulit. Parehas, diba? 0.10. So, ang tinatanong lang sa atin for number 1, for letter A, find the probability that one of the bags will not contain a coupon, that x is equivalent to 1. Or simply, find the probability of F1. Okay, so for F1, that would be equivalent to 5, C1, success of 0.10 raised to 1, and failure of 0.9 raised to 4, diba? 5 minus 1. So, getting our calculator, that gives you 5C1 multiplied by 0.10 multiplied by 0.9 raised to 4. Okay, it gives you a probability equivalent to 0.3281. Okay, letter B. Find the probability that at least one bag will fail to have a coupon. So, at least isang bag daw. The probability that x is greater than or equivalent to 1. Ibig sabihin, you get one bag or more bags na walang coupon. So, instead of doing this with summation, diba? Pwede naman kayo mag-summation. Ang magiging solution nyo with summation would be the summation of 5cx times 0.10 raised to x times 0.9 raised to 5 minus x. And you will get x from 1 until 5 because you have 5 bags, right? Okay. Or instead of this, you can solve for the probability of x greater than or equal to 1. Pwedeng 1, 2, 3, 4, 5. Wag lang walang nag-fail. Okay, ibig sabihin, that would be 1 minus the probability where there is no bag that contains a coupon. Okay, so, ibig sabihin, lahat may coupon. Thus, this will be 1 minus 5 combination 0 times 0.10 raised to 0 times 0.9 raised to 5. So that would be 1 minus 5, 5C0 times 0.10 raised to 0. That's 1, diba? K times 0.9 raised to 5. Okay, it gives you an answer which is 0.4095. Okay. If you're going to do this, it should give you the same answer. Ano? So that would be 5C, sorry. It should be the summation of 5 combination X. Ano ba yan? 5 combination alpha X multiplied by 0.10 raised to alpha X multiplied by 0.9 raised to 5 minus alpha X. And we're going to take the sum of this from an X equal to 1 until 5. It gives you the same answer. Okay. And yeah, that gives you binomial distribution. Okay, just have to remember that you have several trials to do, and then in each of these trials, the probability of obtaining a particular goal doesn't change. One outcome doesn't affect the outcome of the other. Okay, so how do we solve for the mean and variance of a binomial distribution? So if X is a binomial random variable with the parameters P, the probability of success, and N, the number of trials, yan, to get mu, or the expected value or mean, that's simply N, the number of trials, multiplied by the probability of success. That's NP. And for the variance, okay, that would simply be NP times 1 minus P. Okay, or the number of trials multiplied by the probability of success multiplied by the probability of failure. So, example, the chance that a bit transmitted through a digital transmission channel is received in error is 0.1. So, ibig sabihin, for mean and variance, wait, so let me write down, mean and variance, okay, for the illustration here, the probability of getting a bit in error is 0.1. Also, assume that the transmission trials are independent. Let X be the number of bits in error in the next 4 bits transmitted. So X here means number of bits in error. And we will be checking out this bits in error in 4 bits that will be transmitted. And that will represent your number of trials. So find the mean and variance of X. So for mean, or expected value, this is simply the product of the number of trials multiplied by the probability of getting an error. So that would be 4 times 0.1. And 4 times 0.1 simply gives you 0.4. Okay, which means you get an average of 0.4 bits will be in error. And then for the standard, for the variance, that would be equivalent to Vx. And that gives you NP multiplied by 1 minus P. So your number of trials multiplied by the probability of success, okay, multiplied by the probability of failure. Okay, and this will give you an answer which is 4 times 0.10 times 0.9. And that gives you 0.36. So, I think we've done this example in the previous sessions, so that will only validate this solution na po. Okay, so you get on the average a variance, a variability of 0.36 squared bits. So if you're going to get the standard deviation, you simply take the square root of this answer, so you get 0.6. So ayun, yun yung variability or standard deviation natin kung gaano magiging kalayo yung mga values from the mean that we have here. Okay?